Light is a finicky messenger. It tells us a lot about the universe. We know how hot stars are. We know what they're made of. We know how fast galaxies are rotating. All of that information you can get from light. But that information is really the story about what individual atoms are doing, right? The atoms themselves create the light, and they put their own signature of who and what they are on the light. And then as that light propagates through the universe, it talks to other atoms, and the message gets confused. And our job as astronomers is to take that light and disentangle the story. But there's a lot about the stories that you can't just learn from the light. For instance, if I'm thinking about an object like a black hole, by definition, it doesn't emit light, right? So we need some other way to study them.
Gravitational waves are basically what happens when you've got very massive objects that come very close to each other.
One way that we like to explain it is kind of making the analogy of what would happen if you dragged your hand through a pond of water. If you leave your finger kind of staying still in that pond, you won't have any waves traveling on the surface, but you start to move it around, you start to accelerate it, and waves start to ripple on the surface of the pond. Now, it turns out, thanks to Einstein's theory of general relativity, his modern theory of gravity that came about in the early 1900s, we found that a similar thing happens when you move objects through the fabric of space itself.
The Earth and the Sun are actually producing gravitational waves right now because the Earth and the Sun are moving around each other. Just the way that motion works out, it actually produces gravitational waves. Totally not detectable by anyone on Earth at any time, probably for thousands of years. So what has to happen is you have to have something that is the mass of the sun in a very small, compact object, very close to each other, doing the same sorts of motions.
So when you take a heavy, dense, compact object and start to move it through space, it creates ripples that propagate away on the fabric of space.
And the way that affects us is that as they would then travel all of those light years to get to us, then they pass by the Earth, and of course the Earth is nothing to them. It just goes straight through and keeps on going. But what you would see, if you could see it, you would start to see the distance between you and me stretch and then compress and stretch and compress in alternating ways. So those ripples are actually just kind of perturbing the length between objects. And that's really what a gravitational wave is. It's a perturbation on the length, on the path between two objects, any two objects.